Okay, so this is my. Oh, okay. Now it works. So let's just share it. Okay, it's right here now. So it says derive the parameters for sinusoidal models. Blah blah. Oh, these are learning objectives. Who cares? Okay. So we know that a population of animals varies periodically between a low of 700 and a high of 900. So I know my low. Okay, what happened? My min. Okay, it's not happening today. There we go. My min is gonna be 700 at 1 because I don't know. What should we call the variable x?
Population or like
No,
700 things.
Are the y variable, like the y. Let's just call it x. Let's just say let x or let x be the month. I don't know why I'm writing it so close. Be the months or whatever. So basically this is at x equals 1 because it's January.
Okay, yeah.
And then our maximum is 900 at x equals 7 because that's what July is, right?
Yeah.
Sorry. Anyways, so yeah, we have minimum and maximum. Our average, so that we can find like the vertical shift. Oh, actually, this was supposed to be before those problems, so I'm assuming they didn't know about that yet. So it doesn't matter. The average is gonna be 900 plus 700 divided by 2. It's gonna be 800. So, yeah, I guess let's just start graphing. So let's assume I have, I don't know, this is like 0. This is 700. Oh. Yeah, let's just call this whatever 0. 700 and 900 is gonna be here. Who cares about the rest? At 700, wait a second, guys, sorry. Okay, so 700 is our minimum, and we know that it's 700 at, let's call it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There we go. So at 1, it's at 700, which is our minimum. And then at 7, or at July here, it's going to be our maximum at 900. Okay, so basically we know that it's gonna, wait, what is between 1 and 7, like 3.5? This is, I'm trying to figure out a way to draw it so that it makes sense when we're actually explaining.
I think that's fine. You could draw like dotted lines for the maximum and minimum.
Like dotted lines at the maximum and the minimum?
Because I know like a lot of classes use, yeah, that thing, and then they draw like a line through the center.
Oh, okay, I guess. I mean, wait, I don't know where I'm going with this, but yeah. I mean, what is the center between 1 and 7? It's like 3.5-ish.
No, I meant like in the middle, like at 800.
Oh, well, this is like the first one, so I don't think they're expecting them to like do it yet. You know what I'm saying?
Oh, okay. Well, you could just say like those classify your bounds, and so you know the graph's gonna have to look like in between there.
That's true. So yeah, this is our 800 graph right here. And this is gonna give us like our parameters or whatever. So yeah, so basically we know that the graph is gonna oscillate between these 2 points. Okay, so we have the average, we have the minimum, we have the maximum. It's a cosine function, okay. So first of all, we need to figure out the amplitude. Well, let's start with what a regular cosine function looks like. A regular cosine function looks something like, starts here at 1, amplitude of 1, and then 0, -1, and 0. Well, I don't know why actually, like this is y equals 0, but actually. So it's gonna look something like, oh, wow, that looks really nice. It's gonna go back up to 1, like somewhere around here. So yeah, so this is one wave of a cosine function. -1 and 0. Okay, so this is one wave of a cosine function, and basically what's gonna happen is we're gonna have the same thing happening in our graph here. So I know that my minimum here, we clearly have a minimum right here, and we're gonna have a maximum right here. So this looks like we have a minimum right here and a maximum right here. So my graph is gonna resemble this piece between these 2 points. And it's gonna keep obviously like going forward on that side and going like that on this side. Okay. But I don't think we care about the others very much. But what do we know? We look at this and we see that from the middle, the graph oscillates like up and down at an amplitude of 1, right? So from the top and the bottom, this one here gives me an amplitude of 1, and this one here gives me an amplitude of 1. So obviously from here to here, it looks from 800 to 700, that's 100. So this is gonna be my amplitude. Basically, I keep going up and down 100 units. So basically my amplitude, or A, is gonna be 100 units, or 100 people. Are we measuring people? Animals, 100 animals. So, okay, so that's basically that. And then now we need to figure out the vertical shift. So see how this graph starts at 0? It basically, 0 is our baseline, and then it keeps going up from 0 and down from 0. Here, we're going down from 800 and up from 800. So that means this is my new base. So the whole graph was shifted from 0 up 800 units. So I know that my vertical shift, or D, is gonna equal to 800. Because my graph is gonna have a formula of A cosine B x minus C plus D. So I got shifted up plus 800, and my amplitude is 100.
And the reason why like she got 800 in the first place was just because she you have a maximum of 900 and a minimum of 700. The 800 just happens to be like directly in the middle. Yeah.
Yes. Everything, whatever it's in the middle, that's gonna be your vertical shift for cosine and sine graphs. So there's that, and then we got the amplitude. Now we need to figure out our period. So obviously a year, 12 months. So basically our period, which is denoted by the by the equation 2 pi over b, which is our b right here. It's gonna be 12 because we have 12 months. I don't think I wrote months instead of months.
Wait, hold on. Go back to the graph.
Yeah.
Make sure that the period is for the graph itself. Because I know a year has 12 months, but like the graph can oscillate multiple times within a year. It just so happens that
I think this one's just
the period is 12 months, but sometimes that's not the case. For instance, if this section was shortened from 1 to 4, your period would be a little bit shorter. But in this case, the period it goes from 1 to 7, which is 6 months, and then it returns back to 1 after another 6 months. So that would be at 12. Wait, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It would be back at 1. Well, it would be going back to January. So like the whole entire
is it 13 months?
Would be a whole entire year. So that's fine. But yeah, just be careful if the period is ever like not that length, you know.
Yeah, so basically what he's trying to say is that where it starts, like from your minimum to your second minimum, is 1 period, because it's basically a whole wavelength of the cosine graph. Is that what you're trying to say?
Yeah.
Okay. So for this one, it just happened to be 12 months. And we need to figure out what B is. I could just cross multiply. So I end up with 2 pi. 12b is equal to 2 pi. So b is equal to 2 pi over 12 or pi, oh my god, 12 or pi over 6. So that's going to be my period. Or not my period, my b. And then lastly, I just need to figure out my horizontal shift. So let's look at the original graph. This graph starts from the top, from the highest point, the maximum. And then it goes down to the minimum and then up back up again. Here, if I look at this graph, there is no way that this graph is going to reach another maximum from here to here. It's not going to happen. That's the graph would not look symmetric or right. So what I'm going to have to do is I'm going to have to look along the graph until I reach my first maximum, which in this case, if I keep looking here, it's in July, which is my 7th month, right? So it's basically as if I took this graph, because this graph keeps oscillating forever. So this one's going to keep going down. This one's going to like go up and down and up and down. So I'm going to keep looking until I reach my first maximum, which happened to be on 7th month. So that means I took my whole graph. Instead of starting it from here, I started it from here. So I shifted it a total of 7 units to the right. So that means my C has to equal to 7.
Yep.
So it's just going to be 100 cosine pi over 6 x minus 7 plus 800. Okay. Do you approve, Andrew?
Yep.